Hello there, everybody. Hopefully everybody can see and hear me. My name is Trevor Boucher. I am on the NWA webinar committee and pleased to give you another episode of our NWA webinar series. This one is on citizen science initiatives in meteorology, CoCoRaHS, and more, where we have three presenters. One, a former presenter from a presentation we had given several months ago, Dr. Ian Giumenko. He's from the Insurance Institute of Business and Home Safety. We also have vette Aberman, who's the Florida State CoCoRaHS coordinator and Florida State professor at the Florida State College at Jacksonville. And then also Paul Schlatter, the NWS Boulder, Colorado Sioux, and the former 2019 NWA president. So we're going to be talking about a handful of things. I kind of wanted to, this conversation came from a webinar that Ian and his wife, Tanya Brown-Giumenko, gave several months ago about some of the hail science that they had done. And there was an interesting tidbit in that presentation about their use of data sets that are crowdsourced, that come from the public, such as CoCoRaHS. So for this particular webinar episode, we're going to talk a little bit about that, about some of the, just a little bit of a refresher of that particular webinar and where that comes from and how that's used. And then we're going to expand upon that concept of the citizen science initiatives in meteorology. So I'm looking forward to kind of seeing all the past, present, and future as we talk about these citizen science situations and different initiatives that are there. So I'm going to give presenter mode over to Ian so that we can kind of show you a little bit of a refresher of our previous webinar from then. So Ian, refresh us our memory about who you are, where you're with, and what you're doing in your hail science.
Yeah, thanks, Trevor. Yeah, we got a chance to talk a little bit about the IBHS Hail Research Program. Hail is a really big loss driver. So you might have heard the theme there of CoCoRaHS. So we're gonna start off with the H in CoCoRaHS here to kick us off. But hail loss in any given year is basically between 60 and 80% of the total damage that's produced by severe convective or severe local storms every single year. It's a huge piece of the pie, and you might not, that's a little bit of a shocker in the weather community. The insurance world understands that, and this is primarily driven by countless roof replacements. The United States, our dominant roof cover is asphalt shingles. Something like 79% of all single-family homes in the U.S. have asphalt shingles, and they're extremely vulnerable to hail impacts. And we have to replace, thousands and thousands every single year. And that's where IBHS comes in. We have a multifaceted research program that involves a field component to understand the characteristics of hail storms. We've coupled that with trying to translate the scientific foundational work on understanding the properties of hailstones into laboratory testing and improving laboratory testing. But we also have to have a big picture of the risk associated with hailstorms and the characteristics about them. And one of the places that we actually started was taking a step beyond just the storm data, hail reports, and using the CoCoRaHS hail pad analysis and the hail information that's contained within that data set, its citizen science program, to understand just a little bit more, to start us off and kind of kick us into where we wanted to take field research. And in a way, we target different regions to understand hailstorm characteristics. That was all rooted in using that CoCoRaHS data set. I'll explain a little bit more of kind of the uses in the insurance industry as I go, but that's where we're coming at it from IBHS. So if you don't know much about us, please check out disastersafety.org. That's our main consumer-facing website for any kind of research nuggets, things like that. Go to ibhs.org. You can see a little bit more overview of the research we do. But our facility is located in Richburg, South Carolina. That's where our research center is. And the centerpiece is essentially a large-scale or full-scale wind tunnel chamber, but we also do wildfire research in there. We can do full-scale hailstorm simulations. We have laboratory space where we do lots of hail impacts. So please check that out if you're unfamiliar with us at IBHS. And we are the resilience arm of the insurance industry, the property insurance industry. We're set up a lot like the Insurance Institute for Highway Safety that does car crash tests. Well, we car crash test or weather test buildings and building materials. That's what we do, and that's the model we're built on. So I've left this slide up talking a little bit about our research program. Here's some of the great images over the years from the field. Most recently, we were out in Hondo, Texas, 3D scanning the potential state record hailstone in Texas. helping to create digital models of some of those record or gargantuan hailstones to kind of preserve them for future study. You see in the center picture, that's us using our hail crush test device. We actually compress hailstones and measure the amount of force it takes to fracture them. That's how we understand strength. And then the classic conventional caliper, just measuring hailstones. And the upper right is an image of one of our deployable impact distrometers that actually can capture size distributions and that MRI time history of what hail looked like within a thunderstorm. So that's a little bit about IBHS. Let's get to the citizen science part and some of the things that Trevor kicked us off with, and the rest of our panel is going to cover some of the other, let's say, perils, weather phenomenon that we measure with citizen science. So for us, we used all this hailpad data. There's just a vast number of observations that were collected over the years through the CoCoRaHS program, and some of the not just hailpad data, some of the hail observations, and including damage observations made by participants in the CoCoRaHS program. We were able to do some very basic spatial analysis to start to look at typical hail concentrations across the United States. And the region that actually jumps out is that Front Range area that sees more hailstones per square foot. So this is kind of a base starting point for us to understand a bit more about hailstorms. So let's flip that into our world at IBHS. So how would a hailstorm in Denver differ from one in Dallas in terms of hail concentration? Well, it's easy to use this kind of data set to understand that. So we think about all the snowplow hail events that happen in the Denver Metro, always at Denver International Airport. But what does that do to a roof? Can we take that information that we've learned from the CoCoRaHS data set and flip that around and go do some laboratory simulations to see how does that affect a roof, or how does that affect maybe siding material and those kinds of things? So that's where we started with using this kind of data to help guide laboratory testing. And on the field, we want to go capture the fine details of these kind of hailstorms across that region and understand even a bit more. But CoCoRaHS was a great place to start. We're also able to look at kind of ratios of maximum to minimum hail size through those observations, and kind of the higher plains, as you kind of transition up the sloping terrain out there in the central US, you can see a little bit of that signal of what's guiding. And we know the concentrations, we just talked about that, but what's kind of guiding the hail size distribution. Now, a unique application, this can in turn be used to fit size distribution models. And that's where catastrophe modeling has leveraged this kind of information and actually worked to help build in more realistic hail size distributions within the catastrophe model, really looking to do a much better job of pinpointing damage and potential financial loss from damaging hailstorms across the country. So that's just a flavor of some of the things you can do. What I found really cool, I'm going to show some images here of us taking this information and applying it. This is a test we've done in the lab. We did basically high concentration impacts of 1 inch and 3/4 inch hail. And in this particular test, we use about 100 impacts per square foot of basically right at the marginal severe criteria, 1 inch hailstones. And there's a shingle panel on the right. You might, with your eye, pick out a couple of the impact marks. So we were using that CoCoRaHS data set to kind of guide us of what's the size distribution we want to test here. We bring in some machine vision algorithms here, and we can actually now magically see where all the granules on these shingles have been lost. And in our world, when we look at this, we want to understand what's the impact on the roof. And you dislodge those granules, you're going to shorten the life of a roof. You're going to expose the underlying asphalt to ultraviolet, and asphalt will degrade and become very brittle over time. So this is an example of using that information, translating into laboratory research and trying to move the needle to understand building product performance. Now, in that CoCoRaHS data set, there's also great physical observations. So just qualitative observations that the users made of hail damage looking around their home. Now, you can make an assumption that we're looking at damage to a roof that you could see from the ground. I'm guessing most people didn't get up on their roof, and we don't really encourage that. But you can kind of look at the distribution across the span or spectrum of hailstorms to see what's really going on. So we just lumped some of the categories together to come up with kind of a severity scale using all those CoCoRaHS observations from really weather enthusiasts, people like us, scientists that are CoCoRaHS members across the country. And we can put that in box and whisker form, look at kind of the distribution there. And this is just using kind of a severity scale, lumping some of those categories together and looking at the maximum hail size that was reported for those hail events. And it gives us that spectrum. But this is really useful for us in the insurance space what are the damage thresholds, and what does the variability start to look like. So a really fantastic guide. And this is just an application that I'm delighted that Trevor asked me to share from our side in the private sector of how we take these citizen scientist observations and actually apply them to go move the bar and give us some extra information that we didn't have. And we've even used it to guide laboratory testing. So I will send it back to Trev now. It's really been a neat application to see how we can leverage these types of data sets.
When you were constructing your actual field research and all that, was this something that was built sort of around the data set that you already discovered with CoCoRaHS, or did you find that could fill gaps in your actual field research as you were doing it?
So it filled a gap. We knew the mean, the CoCoRaHS gave us that mean base state. And in the field, we're going to take it a step further and look at, how do we map the hail swaths between these storms? One of our big focus areas over the, this year and looking ahead really is that front range region of the Rockies and trying to get a handle on what is the actual size distribution, the true fitted, distributions. And so CoCoRaHS was a great guide into that area to understand the mean characteristics. And that work, we did some technical reports that have been, shared across the insurance industry just to highlight this area. And we've actually seen some carriers come talk to us about higher than normal claims frequencies. And we think it has to do with these concentrations. So for us in the field, we're going to go investigate that even further. So it was a great guide. It set the base state to be able to go one step past where storm data got us.
Yeah, right. So I can see this really being exciting to see that data actually in the field now being not being confirmed, really. You're seeing this climatological data that was provided by CoCoRaHS, and then actually people in the field saying that there's a return on that and actual insurance claims, and then you seeing the same thing with what it actually does to a roof. How does it actually deteriorate roof over time? So that's got to be like fascinating from a scientist's perspective to see all that data come together to actually create an outcome.
Yeah, and that's the role that IBHS plays, especially with the insurance. The insurance industry, can we identify some of the physical science reasons behind why they may be seeing something in their loss data? Or there's another angle, there's the aggressive sales tactics that are often used by roofers. Chances are, you have a hail event, you're going to get a roofer knocking on your door, probably within 12 hours or so. But it helps us filter a bit of that to understand what's going on from the physical science perspective, and that way from a financial risk management perspective. And that's what the insurance reinsurance sector really works in, is they can work on the financial tools to help manage the losses that come. And hail in general, we're talking, it's well north of $10 billion now each year. We're going to be on year 14 that we've eclipsed that mark, and we're probably closing in on the 20 billion in annual losses. And that trend's not stopping. Our homes are closer together. We build bigger. We have more material to replace. And also this year in our COVID environment, think about the cost of building materials. We're going to see some skyrocketing loss numbers simply due to that side too.
Yeah, those are all great points, and I'm excited. This is just one example, and this is just the beginning, leading into all of the different applications for how CoCoRaHS is going to show how it helps our science do what we do. So with that, I'm going to segue over to our next presenter. That is Vette Aberman. She is from the Florida State College of Jacksonville, and she's actually also the Florida State coordinator for CoCoRaHS. So I'm going to try to get her up on our camera, see if we can turn her on real quick. And if you can turn your own camera on there, but I can't seem to do it at the moment. There she is. All right. So hello. And with that, that's a great opportunity to introduce yourself and your background.
Hi, everyone. Thank you for giving me the opportunity to present today. My name is Vette Aberman, and I am a professor of Earth and Ocean Sciences at Florida State College at Jacksonville, in Jacksonville, Florida. And I am the Florida State Coordinator for CoCoRaHS.
Well, awesome. So you're going to be telling us a lot about how CoCoRaHS data is used, probably in not just in the insurance background, but probably all of our different backgrounds. So let me give you the stage here, and you can take it from here. I can see it. Go ahead.
All right, so as most of you know, CoCoRaHS stands for the Community Collaborative Rain, Hail, and Snow Network. It is a nonprofit, community-based, grassroots network of volunteer weather observers that originated in 1998. And we strive to collect and display accurate, high quality, high density precipitation data that's utilized by many professional sectors in various industries. We currently have 24,249 active stations. So these are stations that have made at least one report since May 2nd, 2020. We have observers in all 50 states, including Puerto Rico, the US Virgin Islands, the Bahamas, and Canada. And this is a screenshot of the homepage of our website, CoCoRaHS.org. All right, so this is a map showing active stations by region. Again, for a station to be designated active, they were required to have reported at least one observation in the last year. The dark gray number is the number of active stations in that region, and the blue number is the sum of all the daily observation counts for all active stations in that region. You can see that the Midwest region leads in both active stations and daily observation counts. And 37.8 million of our approximately 55 million daily observation records belong to current active observers. So that's about 69% when you look at it from a retention standpoint. All right, so these are daily Precip reports per year from 2009 to 2020. This is a graph courtesy of Matt Spies. He is the Connecticut state coordinator for CoCoRaHS. So the reports increased by 9% in the year 2020 and have seen a 75% growth over the past 11 years. A lot of this growth in reports last year is actually attributed to COVID-19 and the stay-at-home guidelines. There's an article that was just published in BAMS this March stating a strong correlation between the states with the highest number of COVID-19 cases and the fewest missing CoCoRaHS observations. And it makes sense. This suggests that as more observers stayed home, they were more likely to routinely report their observations. So before I get into some of the specific use cases, I just want to show you all the sheer variety of CoCoRaHS data applications. And I'm actually going to go right to left here. So the drop on the right contains our most frequent users: meteorologists, hydrologists, climatologists, and emergency managers. I'll talk more about those applications a little later. CoCoRaHS data is used in all aspects of academia. And I'll provide some specific research examples shortly, but even in K through 12, taking CoCoRaHS observations in the classroom actually meets several Common Core and next generation standards and learning outcomes. Broadcasters use CoCoRaHS to fill in data gaps and display localized high resolution rainfall totals. Golf course managers and agronomists rely on local precipitation measurements for irrigation purposes. Fisheries use CoCoRaHS reports to determine periods of excess runoff. Roofers flock to an area that's been impacted by hail. Both local and regional water resource managers frequently use CoCoRaHS data. The agriculture industry uses it to predict and assess crop yields, soil moisture, diseases, insects, and other factors that affect the health of their crops. Phenology, which is the study of biological life cycles and how they're influenced by climate variations, is actually one of the simplest processes that tracks ecological changes in species in response to climate change. Mosquito control operations also use our Precip data and maps to determine where and when spraying may be needed. So there are a lot of interesting research applications. I'll share a few of the more unique ones with you, Public health officials use CoCoRaHS rainfall patterns to determine where mosquito populations have hatched in order to track the spread of the West Nile virus. One researcher got existing CoCoRaHS observers to test the pH of their samples to determine whether acidification was occurring. And CoCoRaHS rainfall samples are also being used in the field of dendrochronology for tree ring isotope analysis. They use the stable isotope data in tree rings, soil moisture, rain, and snow to develop a long-term record of storm tracks using stable isotope dendroclimatology to determine seasonality and variability in the precipitation delivery system in the Pacific Northwest. So take a look at these 6 images. What do they have in common? They're all designed by engineers, various types of engineers. And engineers use CoCoRaHS rainfall data when working on road designs, bridges, storm sewers, and flood control structures. They use hail data for developing roofing materials and building airplanes. And the likelihood, magnitude, and intensity of heavy rains have to be carefully assessed and considered in order to safely and cost-effectively handle floodwaters. And CoCoRaHS data isn't just valuable to scientists, it's actually critical for the legal and insurance industry. Insurance companies use CoCoRaHS data to validate claims to make sure they're not fraudulent. And this applies to a variety of precipitation claims and precipitation related claims. So whether they're assessing hail damage, flood damage, crop losses, snow load incidents, you name it, CoCoRaHS data is so localized that it's great for forensics or any type of detailed investigations. When I worked at the state climate office, we got a call from someone who was trying to recreate the scene of a car accident that was attributed to road ponding. And they were looking for the station closest to that specific location, that specific roadway. I think that's when I truly realized the reach and capacity of the CoCoRaHS network and just how many people it could potentially serve. So many of you know that the new climate normals just came out for the 1991 through 2020 period. These images are courtesy of Dr. Chris Daly, the director of the Precip Climate Group. And the graph on the left shows the total number of stations used to calculate the new normals. Currently, 89% of those are volunteer stations. Now, the majority of those are co-op stations, as you can see, but about 20% are CoCoRaHS stations. And the rest are small regional citizen science networks. Now, Chris did tell me that they haven't finished processing all the networks, so there may be a few more mesonettes that make it into the normals, but that shouldn't change the number significantly. And the volunteer percentage should stay above 85%. There are 2 different criteria for inclusion. So east of the 104.5 degree longitude line, a station has to have a period of record of at least 10 years to be included in the normals, and west, to the west of the 104.5 longitude line, it needs to have at least 5 years. And this is because short period stations contribute more noise than signal where it's flat in the east, since spatial climate gradients are fairly minor. But in the west, they actually add information where the more complex terrain is sampled, the better. And because CoCoRaHS was founded in 1998, the previous climate normals, the 1981 to 2010, could only incorporate a small percentage of CoCoRaHS stations. And the only ones that qualified due to the period of record requirements were west of the Rockies. And there were a few hundred of them, I believe. And I found this really, really interesting because these products, or these are products, I should say, that are so widely used, and we're moving away from the stigma that citizen science programs are just there as a hobby, you know, when they're just so much more than that. your personal rainfall data is being incorporated into a lot of important products, and we're making tremendous contributions to science. One thing I like to compare it to is how the traffic apps have evolved over the last few years. Before, we just had maps. Now we have traffic patterns, road hazards, police sightings. And as the density of the network grows and those data points fill in, we start to see a much clearer version of the big picture. And speaking of important products, I know I didn't cover them all because there are so many, but I did list a lot of the agencies that actively use CoCoRaHS data on the left and the way they use it on the right. There's definitely a lot of overlap, so these aren't in any specific order, but the most common use of CoCoRaHS data in operational meteorology is, of course, radar verification and supplementation, followed probably by data visualization for making graphics and maps. Our data is used every day in hydrological forecasts, and to better understand and predict what type of rain events would cause flash flooding. Snowfall data is a big one. There are lots of automated rain gauges out there, but we don't have anything like that for snow. So meteorologists, hydrologists, and climatologists rely on the CoCoRaHS snowfall database for snow water equivalent, snow depth, and storm totals. And we do have an entire network of state and regional coordinators that regularly QC that data. Steve Martinaitis from SIMS just gave a great talk on how CoCoRaHS data provides ground truthing for radar estimated Precip algorithms. FEMA now accepts CoCoRaHS reports to identify and confirm snowstorms that are worthy of federal disaster declarations. NASA uses CoCoRaHS data for hail risk calculations. The State Climate Extremes Committee now accept CoCoRaHS values as well. All types of climate research, flood forecasting operations, and of course, let's be heroes, log your zeros, because it is just as important to drought assessment on a variety of scales and for forecasting seasonal outlooks. You can see the US Drought Monitor here in the image on the bottom right. The image in the middle is from a presentation by Christina Speciale and Jennifer Boat at NWS Albany on gazpacho. This program is used at multiple WFOs in Eastern region, and they create these amazing GIS maps with terrain and zone average rain and snow, and they incorporate CoCoRaHS data. And in the image on top, that is the Global Historic Climate Network, and nearly 23,000 GHCN observations are recorded across the US each day, primarily by volunteer observers. About a third from the co-op network, but more recently, the GHCN began including Precip data from CoCoRaHS, and in 2019, approximately 66% of US daily GHCN observations came from CoCoRaHS. And that is all I have. Thank you very much.
Well, thank you, Vette. I learned quite a bit, and let me tell you a little bit. I'm also a forecaster at the Las Vegas office. I've been to 4 different weather service offices now, and when we do SKYWARN presentations and recruit for CoCoRaHS, I generally find myself citing just a couple different applications, like the radar, being able to quality control our own radar observations, being able to use it for educational purposes, things of that sort. Obviously, snow out here in the West, that's a big thing, using CoCoRaHS to just verify how much snow actually fell, to verify our warnings and watches and whatnot. But I didn't know 90% of those things about like the different applications. And I think that's really going to be helpful for the recruiting process to say that, why would you sign up? Why would you pay to get a rain gauge? Why would you get all this equipment to be able to do this? And why would I wake up at 7 o'clock in the morning and do this every single morning? And I think this is exactly what folks would really like to hear, is that they are involved in the science, and they are helping provide data that allows these different scientists, these different backgrounds, these different areas of research to advance forward. And that's the really cool thing about showing all these different examples that you've shown. So I wanted to ask you, while you were digging into and doing your research about where all these different applications have been, what's one or two of them that were probably the most interesting that you didn't know before and now you do as a result of your research?
Wow. I was just honestly, the climate normals, that was really eye-opening to me, because I didn't realize how many of them are volunteer stations. And when you think about, how many co-op stations have closed, and just how quickly the CoCoRaHS network is growing, that's only going to become more, I mean, it's just going to be more widely used. And it's really, really fascinating. We are actually working now on trying to figure out some sort of data attribution process, because we have so many different people that use our data, just, anecdotal cases here and there. And we never know, especially from the non-scientific industries. So we were just talking the other day about maybe putting a survey on the CoCoRaHS website, and having, people just fill out a few questions about what they're using the data for. Will it be publicly available? What type of data they're looking for? So it would be nice to actually be able to log some of these more unique data requests. But so that is coming, hopefully, and then we'll have even more to share on that. But I will say probably the climate normals and the dendrochronology thing was really interesting. I learned a lot about the mosquito industry during this process, and just how that whole industry uses CoCoRaHS data. And then, and of course,
there was even a mosquito industry in the first place. So that's news to me.
Right, yeah. And you think, being from Florida, I would have known that, but they don't really share this data with, or they don't share the way they're using the data with us. More often than not, it's readily available, it's free, so anyone can use it. So that was interesting. A lot of the engineering applications and a lot of the forensic stuff is really interesting. And honestly, I would like to know more about that, and how many, attorneys and insurance agencies use CoCoRaHS data, and what they use it for.
Yeah, absolutely. And so, like you had said, now that you might be implementing a way to say, why are you asking? Just, maybe something like that. This is just the tip of the iceberg of what you do know. And so we'll be discovering a lot of different applications of this data set, sounds like, moving forward. So you did mention that 89% comes from volunteer observations for the new climate normals, and a good portion of that comes from co-op. And so I'm going to use that as a way to segue to our next presenter. So I'm going to bring Paul back to the fold here, see if Paul can get his camera back on, and we'll revisit here in just a little bit of better. So we'll see you just in a little bit.
All right.
So Paul, she mentioned the good old co-op network. So coming from the National Weather Service, the Science and Operations Officer of Boulder, can you tell us a little bit about some citizen science initiatives that were in place before there was CoCoRaHS? Let me give you the actual presenter here so you can show your slides real quick. You should have them now.
Yep. And audience view is almost updated. Here we go. Okay, let me hit present. Yeah, perfect segue. So I'm going to talk about the varied ways that a typical National Weather Service office uses citizen science to accomplish our mission. Trevor mentioned the Cooperative Observer Network. There's around 9,000 across the United States. The interesting thing is, this probably is the oldest version of citizen science since it started in 1890 with the passage of the Organic Act. In our area, well, in Colorado in general, there's 250 or so. In our area, which is Northeast Colorado, there's about 90 that regularly observe every single day. We provide them with the equipment and they make the observation. Believe it or not, we still get one of our callers or one of our reporters call in the report, and then we put it into the web page. But all the other observers just use a web page to fill out their daily weather conditions. Another neat citizen science effort that was started at NSSL and at the University of Oklahoma, originally to help verify ground truth for dual pole radar, but it just blew up and expanded well beyond that original usage. And this is mPing. It's a free app you can get on your phone, either Android or iPhone. And you can report just about anything. It's all geolocated on your phone, which is nice. So you don't have to take the time to say where you are, say what time it is. It's time coded, geolocated. And then we get it into our main software system called AWIPS in the office. And I just had a really poor example, but there's a rainfall report there, right there. But we can get hail size, we can get just general snow, rain, what precipitation type is it? All those types of things we can get through mPing, and it's very useful. It gets into our operational system, and it's really easy for a citizen to report what they're seeing on the ground, at least in terms of precipitation type. I would say one of the ways, and especially on a day like today when there's a moderate risk across our northeast corner, if we didn't have trained spotters out there, I don't know where we'd be. Our northeast corner of Colorado, out here, there is about as poor radar coverage as you can have east of the Rockies, where I believe the nearest radar is roughly 90 nautical miles from this area in the moderate risk today. So our office has made a very concentrated effort to train spotters through the SKYWARN program, and this started in the 70s. We've got about 11,000 of them in our area. Now you may ask, what does it take to be trained spotter? Basically, and we've been doing them virtual during COVID. It's about a 2-hour presentation led by one of our forecasters that trains them what to look for in terms of spotting severe weather, what the clouds look like, how to measure hail, how to measure snow. We cover it all because we need all that information in areas of poor radar coverage, or just in general. It's good to have a set of eyes on the ground feeding us and telling us what we need to know about the impacts of the ground. We can plot all of their information right in our software AWIPS. So every one of these little asterisks, which I know you can barely see, I'll zoom in a little bit, but you'll see that in cities and towns, we've got excellent coverage, but there's still some areas, rural areas, where it could be 30 miles before we have even a trained spotter available. So that's an issue. We add hundreds to this list every year, easily hundreds. Sometimes we've gotten close to 1,000 in a year adding to this, and we have to remove them each year too, because either they move or they're no longer a spotter, or just their information is no longer valid. Zooming into the metro area, just to give you an idea of just how densely packed our spotters are, at least in Metro Denver and in the foothills, which is nice. This is great for snowfall reports. A lot of these areas we may not have CoCoRaHS. Some of these are CoCoRaHS observers, some of them are not. Either way, we need reports from these areas, because these areas get absolutely buried in upslope snowstorms. CoCoRaHS obviously is a critical part of citizen science that we use in our office. This was for the March blizzard. The neat thing about CoCoRaHS and snowfall reports, we rarely have to QC them. I mean, if we see a CoCoRaHS report that's off, it's because they missed a decimal point. It's so clearly in error, and it's only because they missed a decimal point. Easy to fix, easy to take away, and then come up with really good totals. And you'll notice just how densely populated our CoCoRaHS reports are across the populated areas of Colorado, and even some not so populated areas. So using these reports combined with our trained spotters, we received for that storm, and actually most storms, even just normal storms, not epic, 2 to 3 feet blizzards, we end up getting between 300 and 400 reports. When you split up for this particular event, there are about 350, almost 380 reports. roughly 2/3, a little less than 2/3 came from CoCoRaHS. About a third, a little less than a third came from our trained spotter network. And then whatever was left over was just from social media we picked up. But with 350 high quality controlled reports, we were able to make a really great storm total graphic that's good for verification purposes, checking how our forecast did. And the public just eats this stuff up. They want to know how much snow fell and who got the most and where all that occurred. And that's exactly how we can do that because of citizen science. The final piece, then we'll bring Trevor back in here and everyone else. We will pretty much use anything we can get our hands on that helps us determine, what weather is occurring at that particular site. Whether it's severe weather, is the wall cloud rotating? Is it going to be a tornado? How much snow did you get? How large a hail fell at your location? So we will use pretty much anything we can on social media to help get more storm reports input and those types of things. But the problem is it's a boatload of data. It's hard to mine exactly what you need. And gosh, the QCing is an issue. I can't count how many times someone will post a really pretty picture like this and say, happening now. And then one of our forecasters or even me is like, yeah, that was from a year ago because I remember that photo. So that's clearly not from today. Happens all the time, but there's always a QC element with social media that we have to be mindful of. But still, we'll take it if we can get it and we can use it. So Trevor?
Right, absolutely. And I'm glad that you ended on social media actually as your last slide, because that's sort of where my role in the National Weather Service has actually gotten larger. And then here in the NWA too, because I've been involved in the NWA social media committee. I've led programs in the Weather Service regarding doing exactly this. How do you quality control the data that ends up becoming the fire hose of social media? And it sort of brings us into really the future of where these citizen science objectives go. Data no longer becomes the issue. We have plenty of that, but not all the data is good. And so we end up getting into this quality control issue, as you had stated before. And so I'm going to take something back, and I'm really just going to show one or two things here that I thought were really interesting. One of them being that there is a program. Let's see, get it on the right screen here. There's a program at the National Weather Service office in Nashville, Tennessee, called T-Spotter. And what this concept is, you can just go to weather.gov/Nashville/T-Spotter, and you'll be able to find it there. But what this program really is an opportunity to kind of see SKYWARN move into the future as far as being able to take all of the data that you're finding from people's smartphones, from social media. They're taking pictures of hail, pictures of tornadoes, pictures of lightning, whatever it happens to be. And there's individuals now that are their SKYWARN coordinators, if you will. And what they do is they funnel that information directly to the Weather Service. They're the ones doing the quality controlling on their end. Now, if you think about how a Weather Service office actually operates, there's tons of different jobs. And so there's usually one, maybe two people that are dedicated to social media. And part of that job is to put information out to the world, right? And so that's the part that's really the most time is to be able to construct new content, to tweet it out the world, and then provide your messaging, especially when there's things like tornadoes on the ground. So where does the time go for you to be able to dive into every single social medium, YouTube, Twitter, Facebook, all of those places? Where are you going to find the time to be able to do all of that? And so this is an example of a way that we could actually think about how SKYWARN can be done in the future. Train those individuals to be able to provide that service upwards. And that's another advancement, I think, in citizen science, where you're not just collecting data, but you're also quality controlling that data. You're a moderator. You're somebody directly involved in the issuances of LSRs. And I can think of a couple different instances where the citizen science programs have blossomed, like in NASA, for instance, with the Juno mission. And there's citizen scientists that are actually constructing the color of that down on the ground and then publishing that content for the public consumption. And so there's some amazing ways that I think science is starting to embrace really the idea of citizen science in general. So I wanted to bring everybody kind of back here and show that and give everyone a chance to turn their cameras back on and talk about a little bit about what the future of citizen science really is going to be. And so we talked a little bit about how much fire hose of data that there actually is now. And so maybe we can start there. Do you see citizen science initiatives like this in meteorology, for instance, going away, or do you see them blossoming? So that's kind of an easy one. I'm going to toss to everyone, and feel free to jump in and answer that question. I'm going to try to get a vette back while we're doing that.
Yeah, you know, I'll jump in from the private sector side. I think it's going to grow. I really do think it's a great tool in all sorts of observations. I mean, we're already seeing it. Some of the roadway weather observations. You know, I touched on just a little bit of what we're doing, but in the realm that evaluates damage, loss, etc. There's such a big future in being able to mine that data that the question then becomes is you have this fire hose of information, how do you make sense of it? That's where I think the future, you're going to see a lot of the work put into trying to make sense of all that information and get it in our world in a geospatial format. That's really crucial. So that's kind of our take from the private sector side, especially in the risk and insurance space.
Yeah, and I would have to agree too that it really comes down to what am I looking at when I'm seeing it. And one of the experiments I just got to be a part of was really seeing WARN on forecast, for instance, unfold, where you're looking at very rapid updates of model data that's now a suite that you can be using almost in the nowcast type of way. And so looking at that and then seeing potentially being able to provide the inject of what we're actually seeing in the field right now. And that might not just be reports that are like a hailed stone that's fallen, but maybe it is the evolution of what a thunderstorm looks like, you know, from the field. And somebody's taking a picture of that and submitting that to a place. And now you can see, you know, storm structure, for instance. You can see the lowering of a wall cloud. If you've got live feeds and streams that are going on in the field, that you can actually see that unfold while you're seeing what you think your conceptual model should be building on radar data. So I agree with you too, geospatially being able to have a place where all of that comes together so that you can form your decisions in the nowcast world when it comes to warning operations in the future. I could see this being a huge swing to the how much data that you end up having as a warner altogether. Paul, Vette, any thoughts?
Yeah, I mean, I agree with exactly what Ian said. They're not going anywhere. We're going to continue to rely on citizen science initiatives to help us verify our job and do our job better. I just think it's going to be more, and I hope it becomes more automated just to help us sort through all the data sources that are out there. I mean, there's a smart way to do it, a secure way to do it, where it's not going to feel like Big Brother, but just consider all the different automatic sensors on your phone, automatic sensors on your car, cameras located everywhere. If there's a safe way to allow that information to come to the National Weather Service, I mean, we will use it because we have so many areas that are data sparse where we may have to rely on someone with a phone to tweet it to us, where it'd be better if automatically we could get it in a variety of ways through technology.
Right, and then constructing like the places in which that you can do that. I think one of the things with especially with the weather service world, when you're actually trying to data mine itself, you're just diving in, and so there are people that know that you can, you know, tweet the weather service, or you can submit that via mPing, but that's probably an extremely small subset of what the general public all knows. They know that I can tweet this and then put it out to the world and shout there, and so it's become sort of our job then to be able to take that and find it, and which platform, which place, which word do you look for in order to be able to find that. And even then, if you were to do all of those things, know exactly where to look for and look exactly what word to find, it could just be somebody saying, is that a tornado warning or is that a siren? Like it may not necessarily be exactly what you're looking for there. And so one of the other things too that Ian had mentioned was the geospatial mapping. Social media has already kind of started this as well. There's a lot of places like that they put the reports on the map. Vette had mentioned some using, you know, traffic apps, for instance, that are putting that right there, that you can see, hey, just right in front of me about 2 miles, I know that traffic is coming, or that I know a police officer is there with a speed trap or something like that. And so we're being able to see that. And now how do we take that in the operational meteorology world, in the science, and then in the theoretical world, and how do we use that to our advantage moving forward? That's kind of interesting question philosophically for the next 10 years. Vette, did you have any thoughts on the future of maybe how CoCoRaHS is going to be adapting to this in the future?
I agree 100%. I think this is the way of the future. I think, mPing started it back in the day with the location. I think that is, that's just going to translate across all the platforms. And even with CoCoRaHS, we have lots of technical improvements on the horizon to the mapping system, QC, our app, data integration, the website user interface is getting an update. So lots of exciting things to look forward to. And the more we integrate all that, and as we start using some of those like the artificial intelligence technology and all that, I think that citizen science, I think everyone's going to become a citizen scientist, whether they want to or not. And I think that, that's just going to improve forecasting by, leaps and bounds, just giving everyone a data point, basically. And we still have states where, quite a few states that have, I think in Florida, we have 1 or 2 counties with no observers. I know other rural states out west, especially, it's hard to get observers. And that's where, the Precip out there, that's where we really need people with the low density in population. That's where we need observers. We need data. We don't have any data out there, and it's just, once we get that data, I think that's going to fill in a lot of the gaps that we have.
Yeah, and that's a great point too, is I think, and we talked about this when we were practicing this, was that there seems to be still a stigma to volunteer submitted type of data, that it's inherently bad quality. And I think social media probably had a large role to do with, giving it that bad reputation. And Paul had mentioned it, there's a lot of fake photos that are sent. And we look at it with understandable skepticism. But do you think that that's just an education thing? Do you think that moving forward, it's more of how do we champion these citizen science initiatives so that you're contributing to something that's useful? When I was talking before about, I don't really know the different applications of CoCoRaHS, so I really only had a couple different examples of how to move that forward within the context of being a meteorologist. But I now know from the presentation you just gave, Vette, that there's plenty of other applications as it advances plenty of other sciences. So I think it kind of is now on us to continue to educate folks that you are doing something, and there is an inherent stewardship and responsibility to providing that data, because look what it's doing. What are your thoughts on that moving forward?
I want to jump in. I spent 17 years in observational field research. There's no such thing as a perfect data set. We all know that. Trev, you and I come from the same kind of academic background. And yes, some's better than others. There's always quality control that's going to have to go into it. But I think we all sitting here know that there is no such thing as a perfect data set. So taking what you can get out of it, and like I'm thinking about just those CoCoRaHS, those damage observations that I've worked with. What a really great tool to be able to just explore how people see hail damage. Yes, we had to quality control some of that out. We had to work on, do the times line up and all that stuff, even merging some radar data with it. But I think the future is, mPing scratched the surface of what mobile device applications can do. I think that's just going to grow. There's even, work on, can you 3D scan a hailstone using your phone and just stitching together images, building apps off that. So it makes hail reports so much better. But think about the potential to engage kids with science through all of this stuff. And that's what really kind of gets me going. I really love that these things can bring those opportunities to just a myriad of kids who might not get exposed to science, and it might trigger just them wanting to dive in and learn more. We had a really good example of this. Our team went out and 3D scanned the Hondo potential Texas record hailstone. Well, the homeowner who saved it, her grandson, who I believe is 10 years old, is interested in weather. And so she saved that hailstone because he was interested in the weather. And I got to hear our group story about we gave the 10-year-old a 3D printed stone. I think it was the Colorado record, Paul, and we just happened to have it with us. And they told me just seeing his face light up. And these kind of applications can introduce science to so many people. And I think the benefits far outweigh some of the negatives that are there. But we have to quality control all our observations. So that's kind of my 2 cents on it.
Yeah, absolutely. Totally with you there. We have it's 56 past the hour now, so our goal is an hour or less with these webinars. So now that we're kind of there, I think that's probably a great place to wrap it up on that sentiment there. And so I wanted to thank all of you, Ian, Paul, and Vette, for being here and talking about citizen science. Ian, especially for following up on your presentation from before and really being the inspiration for this particular talk, and Vette sharing with us all this content that we can now take with us into the field of the National Weather Service, for instance, and continue to recruit for CoCoRaHS. And then Paul, of course, you had mentioned you have part of moderate risk going on. So you being here and then being a part of this, I really appreciate you guys' time. I'm sorry that we didn't have a lot of chance to get to questions from from the audience. We didn't actually have some, but because we had that discussion, we were going back and forth. I wanted to keep that going. So again, thank you everybody, and everybody watching. Thank you for being here on May's webinar. We'll have another one next month. Keep an eye out on the NWA social media and on our webpage at nwas.org for the next topic that we'll be discussing coming up very soon in June. So thank you very much, everybody, and we'll see you next month.